Ah, okay. Oh, and then, okay. I'll post the bonus. All right, hello class, how y'all doing?
Mr. Sylvester, I got a question.
Callaghan, right? Callaghan, how you say that?
Yeah, I sent you an email. I
When?
accidentally submitted the wrong program, but I submitted it in the comments section. As soon as I saw you said I submitted the wrong program.
Oh, yeah, so you want me to check comments.
Oh, well, I sent an email too, but
Want me to grade a comment. Boy, I tell you. So you sent the other one through the comments. Mm. That was the one where what it
it was
was.
program 3, chapter 2, program 3.
Right. I think you sent the one of the earlier assignments.
Yeah, I sent that one on accident. I don't know. I guess I got my files mixed up.
Now, like I said, you have that file.
Yeah, I submitted it like as soon as you said something about it.
Yeah. But when did you complete your file?
I've been completed like weeks ago when we were supposed to, not when
Uh,
you gave us extra time to do it, like the week
okay.
before that.
Let me ask you this: did you go back and look at it, make changes to it, or whatever?
No, I didn't make change. I didn't have my computer for 2 weeks.
Okay.
So,
So you did not open it.
uh-uh.
Okay. So if you did you email the assignment in the email?
I sent it in the comment
No,
section
no, no.
because, like,
Nah,
under where you told me.
I know. Send it to me as an attachment. And what I'm going to do, I'm going to look at the metadata and look at the last modification date and whatever, and
Okay.
see. Right. Yeah.
Okay.
Yeah. Because in the comments, all you did was copy and paste it.
In the comments, I just went in
Upload
the
it.
comments and I submitted my program 3. Like, all I did was submit the file. I didn't open the file in Xcode or anything.
Right. Yeah, but in the comments, well, I might be able to download. Let me
Yeah,
see.
you can download it in the comments. It's like you click on it and I think it might pop up. I'm pretty
Right,
sure.
but see, that's what I don't want. I want to be able to look at it as a file. You know what I'm saying?
Yeah, I don't think it's gonna open in Visual Studios when you open it.
No, I'm not even talking about opening.
Oh,
I want to be able to just if I can download it as a file. Like you do an email, you download it,
mm-hmm.
and it doesn't open it. It just copies it to your drive, and then you can look at the properties of the file.
Okay, yeah,
I don't want to look at the inside until I look at the properties.
okay.
Yeah, because a lot of times they have like I said, the computer name, the date it was created, the date modified, and all this other stuff. Yeah.
All right. I'm
So just
sending it.
email it as an attachment and put on it wrong file submitted or whatever for whatever.
Okay.
Right.
I also
Yeah.
sent you an email because I was really confused because
You said you sent me all these emails. Let me see something.
I sent you one email.
No, what I'm saying, I don't recall all those emails. And what's your name again?
Hallie Callaghan.
Callaghan. C-A.
Lleggan.
L-E-G-A. Okay. You did on March 1st. That's yesterday, right?
Yes, sir.
Okay. Older. Let's see. Yeah, because I didn't. I responded to one. You had a question about variables.
Yeah.
And then another one I didn't respond. It was about solo learn. Or somebody whenever you log in, whatever. And then this one, that's not, but you had some older one. Needed to forgot why. Oh, okay, on the assignment. Yeah. Yeah, you were just questioning me about why you got that too. Yeah. And that was because of, the wrong assignment. So like I say, just email it to me and I'll look at it and see what's what. And then I'll go it on and look at it.
Yeah, I just emailed it to you just now.
Okay.
Did you see did you read my email from yesterday?
No, I just saw that you sent it. Let's see. Yesterday, March 1st, March 1st, March 1st, March 1st, March 1st. No, I hadn't even opened it. Okay, let's see. Now, what bonus assignments?
It was compiling a C++ program where it like just shows you how to download Visual Studios.
Right.
Another one was Netiquette.
Right. What about them?
Oh, I don't know what the other one was. It just was saying I was just really confused because the compiling a C++ program, it was just showing instructions, but I still got a 0, so I don't know.
Did you go through it though? Did you look at the video? Did you?
No, because it's Visual Studios and I use Xcode.
Right, but it's still, how would I say it? It was a class, it wasn't an assignment, but bonus.
Yeah, but if it was bonus, why would we have to do it like straight away if it's bonus? Like,
no, you don't have to do you don't have to do it.
Oh.
But if you don't do it, I can't give you the bonus point. You understand?
Yeah, but it brings down my grade. It's in the thing as a 0.
Right, because the grade is a part of that 5% bonus. If you understand what I'm saying. All right. Remember at the beginning of the semester, I said you have bonus, you have quizzes, you have tests, you have assignments, and you have the final, right?
Mm-hmm.
Now, the tests, the bonus, I'm going to scratch that. The tests, the assignments, the final, the quizzes, and participation. That's the other. Those add up to 100%.
Mm-hmm.
The bonus that you see out there, outside of something I just say, okay, well, I'm gonna give you a bonus in assignments or whatever, but it's gonna be as assignment. When I do that, that's gonna be a boost. But if I put something under bonus, that's under that 5%. So it can't give you points if it's under that 5%. You got what I'm saying? You either do it and or you don't. If you don't do it, it's going to reduce that 5%. Mm-hmm. So you can't get the total 5%. Because if you look at it, you can get 105% average in the class without any other bonuses. Because that bonus section is 5% of your grade. Well, extra 5%, put it like that.
So it doesn't count against your grade, or
no? It shows that it counts against it because it's added in as 105%, you know?
Uh-huh.
Right.
But it isn't actually?
No.
Okay.
Look at it like this. How would I say? Like I say, you got your test is 30% of your grade, right?
Mm-hmm.
Your final is 20%. So that's 50%, right? Mm-hmm. The assignments are 35%. So that's what? 35 and 50, that's 85, right? Mm-hmm. Then you got, I think your quizzes are 10%. No, yeah. Quizzes are 5%, which is 90. Then you have, no, that's right, 10%, which is 95. And then you have your participation, which is 5%. So that's your 100. But then the bonus that you see in Canvas is that 5%, which makes it 105. So you
Okay,
really
I
look
get it.
right,
Yeah,
right.
I get it
So
now.
right. So if you don't do nothing in that bonus section, it will take your grade down. You got me?
Mhm.
But if I just say, oh well, I'm gonna just take off the bonus, then everybody grade gonna drop by that. Well, not may not be five. If they did everything, it'll drop by 5%. Well, it'll drop maybe a good bit. But if they hadn't done anything, it'll stay the same.
Mhm.
Right, right. Well, it dropped that 5%. My fault. So that 5% is just added on to the 100 because I grade you out of 100, 90 to 100, 80 to 90, on and on and on.
Yeah.
But you really got opportunity to do 105. Yeah.
So how do you grade participation?
Me, like when I'm doing, like when I have class, I don't, I like I tell the students, I don't grade participation in a sense. What I do is I tell the class, and you notice a lot of time when I'm lecturing, I ask a question, right?
Mhm.
And then so it's random. So as long as I feel, or not even I feel, as long as students are communicating, or because if I have a student that said, "Oh, well, Ms. Vest, I just don't want to answer. I'm not going to answer today," then I'll say, "Oh, okay." Then I'll start saying, "Okay, participation. We're gonna do it this way." But outside of that, if I call on you, and like I said, I don't want to force you to do anything. But at the same time, we should have a rapport to where, you're not just being, oh, I'm not going to answer or whatever. I'll give everybody the participation points because, it encourages people to ask questions, interject, and whatever, you
Yeah.
know. So that's how I do it. So basically, everybody get those points because of the way the class go, the way the class go on. You got me?
Mhm.
But when people start like, well, Mr. Vessel, you can't make me, or I'm not going, well, okay, well, then that's when I'll say, okay, well, I'll start, whoever participate, get participation points, whoever don't. Right. But everybody get that. So you get those points. Yeah.
Okay, just
Yeah.
making sure.
All right. Anything else? Any other question? I know somebody had an issue. I forgot who it was with the test. For some reason, I don't know what happens at times. I don't know if it's my system or what. I know I had to reload. I think I did a reinstall of my Chrome, and I think it dropped the Proctorio, and so the student was telling them input a password. So I didn't see the message till about, I think it was like 11 o'clock, 10:30, 11 o'clock last night. I went in and went through the setup and whatever, and then it was set. So I don't know if they got on, because I sent a message out after that it was fixed. So
Yeah, for some reason last night, you're right. I had the same issue earlier in the day when I was
right,
trying to take the test. Proctor got
right.
an uninstall for me too, and I was trying to figure out why that happened.
That was on my end, I think, because if the teacher don't have it set up to where it sees the Proctorio, then you'll see a password. You know what I'm saying?
Yeah, yeah,
Right,
yeah.
right.
But it was weird because at the same time, I had like the triangle with the exclamation point and
No, but
everything
it's
to
not
ring
on
me
your
up.
end. Yeah, it's not on your end.
Ah,
It's on
okay,
my end.
okay.
Yeah. And remember, I told you, I don't know if it was Saturday or Friday. I reloaded my browser, and I think when I did that kind of took that extension out, and I had to add it back. Once I saw that email, I added it back, and then I sent an email to him saying that it should be working. Yeah, so I'm gonna have to be aware of that too. Yeah, it wasn't on your end; it was on my end. Yeah. Any other questions? Questions? All right. And also, like I say, some of y'all still not submitting your header files. Some of y'all not including your header files in your assignments. I want you to get used to that. Get used to that. Get used to that. Because next semester you're going to be heavily dealing with functions. And if you kind of can get used to it now, you have less issues understanding functions when you get to that next level. Because we'll get to functions toward the end of the semester, but like, I want you to kind of get familiar. Stay in tune with using functions. Like I said, you could just write, once you write the one header file, You can use the same one, just modify the dates and whatever, and use the same one. So, like I say, try to make sure you get that working. All right. Okay, so we kind of, I don't think we got too much into chapter 3 on last class period. And like I said, I didn't post the lecture on last class period because we was wrapping up chapter 2. But I'm gonna post that one and this one, and we took a test, so it wasn't much. So what I'm gonna do, I'll post both of them after I get this one generated for this class period. So let me share my screen. Any other questions, class? Any other questions? And now, like I say, midterm grades, what I'll do, I'll just take whatever the grades are we have, whatever, and I'll submit that for midterm. All right? My nose running. So I'll just submit that for midterm. So make sure you do all your work, get all your stuff turned in on time. Okay. Now, so everybody should know how to use the CN statement. What the CN statement does, it allows what? A user what? To input data to be read into the computer. And what? The CN statement is normally accompanied by or preceded by a what? A cout statement, so that what? The user will know exactly, well, I ain't gonna say exactly, but we'll know what to do, whether it's to input a number, whether it's to input a character, whether it's to input a string, whether it's to put in 2 numbers at one time or whatever. So a CN statement is normally preceded by a cout that would be telling the user what to do. Now, if you notice, look at this output here. And in mine, normally I'll make it go to the next, or I'll do it on the same line. Some students make the input on the next line. That's no problem. All that is, and this is a program that we was dealing with. All that is if I wanted, like just say, please enter first value. Looking at this does not go to a new line. I got a space here. So what? When I do the CN, the value will be inputted right at the end of the prompt. But if I would do something like this, if I could tell you, then what? It'll say, please enter value, and then go to the next line and want you to prompt the value. All right. So what I'll do, I'll show it to you. All right. This is a program I did with my 193 class, my 192 class. So watch. See here, please enter first value. Now what happens? It prompted the user with this, and then what? They said in line. So they went to the next line, and this is where we input an X. So if I put in a value, then look at the next one, but the next one does not have an inline. So what? Whatever that value is, and will that be inputted, it'll be input there. So if I hit enter, notice the value will be inputted here. All right. So I just want to kind of give you insight on what's happening, because some people look at another person's program and say, "Oh well, why mine is doing this and mine and yours doing that?" That's the only reason, because they don't have inline at the end to carry it over to the next line. Right or wrong, it's programmer, and I can say programmer style, and or it would be the requirements of the program. All right. Because if somebody say, okay, I want you to write a program to prompt the user of a value on the same line as the prompt, boom. So they give you a specific way to write the code. All right. But other than that, hey, it's going to do the exact same thing, give you your results or whatnot. All right. So that's all this program was. Now, so that's the cout statement. The CN statement. And it tells you here a CN is normally accompanied by what? That cout, telling you exactly what it is, or telling you what it is you need to do, and maybe why you inputting that value. All right. So, and now it shows you, because sometimes you may get confused, and like I say, as you programming, it may take time to understand. But what's happening is when you do a cout, whatever you have on the left side, it's being sent or streamed to the cout, which is console out. So when you do cout, your arrow should point toward the command C out because the information is being streamed to the console out. But when you do a CN, the information should be streamed into those values so that what? The arrow should be pointing to the variables. Okay, so that's how you can kind of understand it. But like I say, you may have your own mechanisms for understanding why the arrows point one way or the other way, right? Now, it tells us, or you must use the diode stream. So input, CN, output, C out. So this header file must be used when you use the CN, in the C out statement. Now, entering multiple values. Sometimes, just sometimes, and I think I have in my program that you're going to have to do, specifically, please prompt, well, how would I say? Please, I have it something like, please enter 5 values all at one time and find the average, okay? Or using one CN statement, okay? What that means is I have to do what? CN, first variable, stream, second variable, stream, third variable, stream, whatever. So I could stream in and put values in as many variables as I want, as long as I have my setup CN, then stream into this, stream into this, stream into whatever, on and on and on and on. All right. But the user will have to know how many different values need to be put in. That's the only difference. Because if I do CN length, stream length, stream width, and I just put in one value and hit enter, the prompt will just be blanking and it'll be waiting for me to put in another value. So what happens is your prompt need to be very clear as to, for the user, as to what they need to do. Like, what would be a good prompt for this CN statement, class? What would be a good prompt for this? If I'm using this in my program, and we said a CN is normally a C out is precedes a CN, what would be a good prompt to put if we had this statement prior to this statement? Anybody? Hello?
Just like
Okay.
Answer that question again.
Please insert the link followed
Answer
by
the question. I mean, what was the question again?
What would be a good prompt to prompt the user with if you had this statement as a CN statement? Somebody was saying something.
I was saying, I guess just like, please input the length followed by the width.
Correct. So now you know that what? You have to put in 2 values, right? Right. Now, the thing is, being that I didn't program, it's like I would say, please enter a length separated by, and the width separated by a space. You understand? So it's like, because when I put in one number, if I separate it by a space, that's the next number. So it's going to accept the first one, it's going to see the space, then it's say, okay, where's the next one? Accept the second one. All right? But on the other hand, if I just had CN values, all right, with an S, if you're not the programmer, you don't know how many values to input, right? You might not know how to input them. Somebody might put whatever, comma, whatever, comma, whatever. Or somebody might put whatever, dash, whatever, dash, whatever. So which might make the program blow up. But if you say, please enter a length and a width followed by a space, the values for a length, then it's like you kind of giving the user some specifics as to how they input the data and what they are inputting. You got what I'm saying? So you got to be sometimes more specific because you can't look at it as, well, I'm writing a program, all you do is put this. But somebody who just getting to the computer and they won't know exactly what to put in. And then all of a sudden now you got to go back to the drawing board and rewrite the code or whatever. So look, enter the length and the width of a rectangle separated by a space. So that means these two values are being inputted at what? The same time. All right. But now, with C++, you can do it. You can input them separately. It won't harm it. I could type in a length and hit enter, but it still will what? Wait. The compiler will be waiting for the program will be waiting for me to input that second value. Then when I put the second value and hit enter, it will continue to execute the program. So it won't cause any issue if you just put one, but the prompt says to put in the first one and the second one, separated by a space. Okay. All right. So look here. When they executed the program, they typed in the number 10, hit the space bar, they typed in the 20, and then they hit enter, and the program continued to execute. Now, like I said, they could have typed in 10 and hit enter. It'd have just been waiting. It wouldn't have put a prompt. It'd have just been waiting for the next value. Type in the next value, hit enter, and it will go through and complete the program. All right. So that's all it's saying what happens there. All right. Now, this program demonstrates how CN can read in multiple values of a different data type. You got to watch when you're reading different data types, because what we said about integer values receiving float values, what happens to the remainder of those numbers? When an integer receives, like say, if I have I have a variable x, which is int, and I'm trying to assign in the value 23.5. What's going to be stored in x?
Just 23.
23. So you got to be mindful when you're dealing with variables of different data types and you're reading them on multiple levels. Even if you're not even reading them reading them at the same time. Even if you're not reading them at the same time, it could cause issues. But look at this. This program reads in a whole number, all right? Or they say, please enter an integer, a double, and a char. But then look, line 13 says, line 13 says CN whole. So a whole number, they put in 4. Fractional, they put in 5.7. And letter, which is char, they put in B. All right. Well, look at it here, my phone. This is where they put it in. 4 space, 5.7 space, and B. No problem. The 4 is integer, the 5.7 is decimal, and the B is character. Now, but look what happens if a person mistakenly put in the wrong value, not say the wrong values, but different data types. So look here, enter an integer, a double, and a char. That's what you were supposed to enter. They entered 5.7, 4, and B, and hit enter. What happens is this throws your data off totally. And what I mean by that is an integer, what will be accepted for the integer part? Only the 5. Everybody understand that? So the 5 will be put in whole, but you still have 0.7 space 4 space B. So in that buffer, it's going to say, okay, I'll put 5 in the whole, but now I still have remaining data in my buffer. So I'm going to put the 0.7 in the fractional, and then I'm going to put the 4, because 4 can be a char, and then put 4 in letter. So all of a sudden, your computer read in 5, 0.7, and 4. And that B will be held until there's another CN, and it'll be stored in that CN. You got what I'm saying? So you got to be mindful of your data and how you're putting the data in. You got to know that that data matches what you're trying to put in, because it can cause problems. The 5 will go into the integer, the 0.7 will go into the fractional, and then the 4 would go into the letter, and that B would be left over. And if your program running and it sees another CN, that B gonna automatically be put in that statement. And what happens if it said if that B was left over in the buffer and you had a CN for char, B would be put in it. Now, if that B was left in the buffer and an integer was requested, then it would take the B and convert it to what? Its integer value. Everybody understand that? So it will work, but it's just gonna cause your data to be all messed up. All right. So you gotta be mindful. You gotta be very mindful when you're reading in data, multiple data of different data types. All right. Now, mathematical expressions. It says C++ allow you to construct complex mathematical expressions, all right? And there also are functions that you can use to accomplish this, using multiple operators and grouping symbols. So what? We can use the parentheses and whatnot to group our data. Now, what are the operators that we use? The common ones, we have the plus, we have you have addition and subtraction, which is plus and minus. But then you have one of a higher precedence, which is multiplication, division, and the modulus, which is the asterisk, the slash, and the percent sign. All right. So simple addition, this plus this, and it solves it and stores in the sum. Remember what I told you. Anything on the equals on the left-hand side of the equal sign is where the value is being stored. On the right-hand side is where the expression is being solved. So you solve on the right and assign to the left, always. If you on a computer and you see, and it's in a program, and you say 21 plus 3 equals sum, you know automatically that's wrong. That statement will not work. Something is wrong with that statement. You solve on the right, left, and assign to. You solve on the right and assign to the left. Always. All right. You got to remember that. All right. So look at this. Look at some expressions. All right. This is an assignment statement. Result equal X. So whatever X is, it stores in the result. Result equal 4. It take the constant 4 and stores into results. Result equal 15 divided by 3. Now let me ask you this. Who can answer this question? What if results was of double or float? What value would be stored in? What output would you get? If this was double or float, and I did 15 divided by 3, what would be the output?
Would it be 5.0?
Nope.
0.00.
Nope. This is, y'all forgot what happened, what we talked about last class period? Watch. I'm gonna take all this up. I'll just take all this up. Take it up. I'm gonna take all this up. Remember we talked about int and int? And I remember that? Let me take this up. All right, if I said float or double? So okay. Equals by 3. All right, so int divided by int gonna result in a what? Int. Y'all don't remember that? We talked about that. So when I run this, I'm gonna get 5 with the output. An int and an int going to result in an int. Where's the output in? Okay, yeah. See, I'm going to get 5. But if I change any one of those to 3 or 3.0 or 15.0, what happens? An int divided by a float, it promotes it to a float, and now it's going to print out what? 5.0.
Yeah.
Yeah, y'all remember we talked about that at the end of the, I think it was toward the end of the class period. Oh no, it's still giving me
That's important though.
right. Wait, it's still giving me the 5. This is double. This is double. Wait a minute. That should have given me the decimal. Why didn't it do it? If only one of them, it should still give me the double. Because we went over that last class period. I know why. Because, let me do a 10. 10 divided by 3. Gonna give me 3. Because there wasn't no decimal place. So this is gonna give me 3, right? But then if I do 0.0, n divided by a float, now it's gonna give me the 3.33, whatever, with the scientific, with the default significant digit. So you see what happens? Okay, it was even. That's why I didn't do it. So it's like an int divided by an int gonna yield an integer result. But an int divided by a float or a float divided by an int gonna promote that result to be of float. And it'll store that float value in here. All right. But if I'm just doing, if everything on this side is integer, it's gonna store an integer value here. All right, into that result. All right. So you got to be mindful when you write your code. So here, results is equal to 22 times number. So whatever numbers is, it's gonna multiply it. If it's 2, that'll give you 44, and it'll store 44 here. Remember the size of. Remember, int was 4, short was 2, char was 1, double was 8. So that's the size, the byte size of a value being stored in that data for that data type. So that's the size of int. It'll store 4 int results. All right. Then here, results is equal to A plus B plus C. Whatever A is, whatever B is, and whatever C is, add it together and you get a value stored here. All right? So now, here is a program where they got a numerator, denominator, 3 divided by 16, and you got a float value. Now, where is the program? All right, see, they got double. All right, these two are double values. All right, and what they did, see out numerator divided by denominator. As I told you before, we don't like for you to program in this fashion. And what I mean by that is, see out this result, see out this expression. Nothing's wrong with it, but at the same time, most times in programming, this result is needed somewhere else in the program. It may be needed multiple times in the program. So when you do a see out this divided by this, and then you need it again, you're gonna have to what? Try to rewrite that expression somewhere else. But if you store it in a variable, you can take that variable and use that value in multiple places in your program. But like I say, is it wrong? No, it's not wrong. But sometimes it can cause issues because what? If you got to try to write this expression multiple times, it may come a time where you write it wrong. You might transpose the numbers, the numerator and denominator, and get a different value. Because I could divide either one by itself, as long as it ain't divided by 0, and I'll get a result. I won't get an error. So look here, precedence. Now this dealing with a little bit of your math skills. We do know that you always multiply and divide, provided that you don't have, your information is not grouped. You always multiply and divide before you add and subtract, all right? But like I said, we have to add one more operator, and that's that modulus. You always multiply, divide, and do the modulus before you add and subtract. Like I say, the grouping does change that things, but just that's the rule. So if we look at this, 17 plus X plus 21 plus Y, there's no precedence here. You just add them all up. Whether you add them forward, backwards, whatever, you get the same results. Now, but look at this one. 12 plus 6 divided by 3. You cannot add 12 and 6 before you divide 6 by 3. Because what? Division have a higher precedence than addition. So, and nothing is grouped. So I would have to divide 6 by 3 and get 2, and then add 2 to 12 and get 14. Because otherwise, if I'm starting from left to right, I would do 12 plus 6 and get 18 divided by 3, and you get 6, which is what? The wrong answer. Everybody got that? So you got to understand the precedence. All right, got to understand that. So look here, and they just showing you. You divide 6 by 3, and you get 2. 12 plus 2 is 14. Now, if they had parentheses, like I said, open parentheses in front of the 12 and close parentheses after the 6, then that would change things. I would have to work from the inside the parentheses out. All right, but that's not the case here. All right, so the unary operators. So you got the asterisk, which is the multiplication, division, and modulus. Then you got plus and the minus. All right. So now
I got a question. What's that symbol right there that looks like a percent?
that's what it is.
Oh, okay.
The modulus. Yeah.
Yeah, what is that?
All right. Let me ask you this. Well, I'm gonna explain. The modulus returns the remainder of a division problem. All right. Now let me ask you this. What's 3 modulus 2? The remainder. What's 3 modulus 2? 3 divided by 2 is what?
1.5.
Nope. But see, you can't look at it like that. We gotta do that old division. Well, remember when you were like in what? I think it's 4th grade, 5th grade. 3 going to 2 one time. 3 minus 2, you get 1. Can 2 go into 1? No. So I have a remainder of what?
1/2.
No, a remainder of 1. You understand?
Like old school division, like you were saying.
That's right. It's like that old school where you getting that when you first learn how to divide.
Yeah.
You got me? Well,
Yeah.
okay. What's all right? What's 5 modulus 3? How many times 3 go into 5?
1 time.
And then okay, if it go 1 time, how many left over?
2.
That's the modulus.
Oh.
You see?
Oh, okay.
That's the
That makes
modulus.
sense.
Right, that's your modulus. Right, there you go. So if I did 17 modulus 5.
2.
Right, 2. 5 going to 17 3 times. So because 3 times 5 is 15, 15 from 17 leaves you 2. Right? Your remainder. All right. So that's the modulus. And look, the modulus, how would I say it? Depending on what you need to do in the program, sometimes you may need to find the modulus of something. You understand? Well, matter of fact, we just did a program, right? Didn't we do the program with the feet and inches?
Yes, sir. Yeah, we
Right.
did.
So when we had to find out, okay, say take 14 inches. Miss who that was? Miss who?
Hallie.
Miss
Hallie.
Callaghan?
Yeah.
All right. Take 14 inches. And if I asked you, what are the remaining inches, all right, of 14 inches? I'm getting the feet, but what's the remaining inches? What do I have to do? I have to take what? The total inches and find the modulus of 12.
Mm-hmm.
So divide the 12 going to 14 how many times?
1,
With a remainder of
2.
so you see that's 2. Well, we didn't do the 1 feet, but it's like 2 inches, that's left over. Because we found the feet by just dividing by 12 and storing it into an integer. And we find the inches by doing the modulus, and which is the what? The remainder. And that's how that last assignment was to be done. All you have to do is add those 2 numbers, divide by 12, and store it in an integer, and then do the same total and do the modulus of 12, and that's your remainder. And then write out your output. So that's how simple it was, but you had to figure it out, as to what to do. All right. But the modulus is the remainder. That's all it is the remainder. All right. So here, this just gives you some expressions as to what their values. And I'm not going to look at calculate the value, but we'll look at the process. 2 times 4 plus 5. It has to do this first, then add the 5. 10 divided by 2 minus 3 is going to do the division first and then the subtraction. 8 plus 12 times 2 minus 4 is going to do this multiplication here, then it's going to add, then it's going to subtract. It's got 4 plus 7 modulus 2 minus 1. It's going to do the modulus of this, which is going to give you what? 1. Because any number modulus 2, if it's odd, you're going to get 1, right? So you get 1. So that's 4 plus 1 minus 1 is 4. So 6 minus 3 times 2 plus 7 minus 1 is going to do the 3 times 2 to get 6, and then they're going to start from the left, 6 minus 6 plus 7 minus 1. All right? So that's how you do it. Now, it talks about the associative property, where now we can what? Group data. When you start grouping the data, that takes away that precedence many times. Because what? Now you have to work from within out and then solve. So if you look at this, 5 minus 3 plus 2, and look at this, 5 minus 3, and then add the 2, really, both of these will perform exactly the same because the precedents are the same. But actually, this one starts 5 minus 3 and add 2. This one does the same thing, 5 minus 3, and then it adds 2. But look at this one. 12 divided by 6 times 4. All right, they're going to do the 12 divided by 6 times 4. But it could have been grouped a different way. But still, you work from within the parentheses outward. All right, but the same precedence, there's really no change. All right, so now it's showing you these
Bro, how am I dying so fucking fast?
These operators. So it's like so it's telling you left to right, left to right. So look at this. Result is equal to A plus B divided by 4. So what you're going to do here, you're going to solve this, all right, A plus B, because it's within the grouping, and then whatever that result is, divide by 4, all right? And they give you examples here. You're going to add first, then multiply. You're going to subtract first, then divide that into 10. You're going to subtract this first, then you're going to multiply, then you're going to add. You're going to add this first, then you're going to do modulus of that, and then subtract. You're going to subtract this, you're going to add this, then you're going to multiply, and then divide, all right? So those are the things, the processes that you have to follow, because that's the way the computer will perform it. Now, you did a program, not a program. Did we go over chapter 3? I'm looking at this. Let me see. No, because our last test was on chapter 2, right? Or 3. Right? In class? Yeah, our last test was test 2. I wonder why. It's like, it seemed like I'm repeating. Let me see something. Module. Our last test was, yeah, excuse me. Our last test was test 2. All right. So I guess it just repeats some of the stuff, but I don't normally think it would do that. All right. Because these are some of the assignments we had. The last assignment it wasn't as complex as this, but the assignment somewhat came from this. 6b is really equal to 6 times b, which is equivalent to 6 asterisk b, right? Then 3 in parentheses and 12 in parentheses is really 3 times 12, which is 3 asterisk 12. Then 4xy in mathematical expression is really 4 times x times y, which is 4 times x times y. All right. All right. And like I say, look like we went over this already, but we'll go over it. Here we have some algebraic expressions, and we as computer scientists, we have to know how to break these things down so that we can get the what? Correct results. So look, y is equal to what? X divided by 2 times 3. Because what happens is you could take this and put a parentheses around this, this x over 2, and that's x over 2 times 3. All right? So that's in a sense how they did that one. 3 divided by in groups, x divided by 2. All right? So, and then here, 3bc, 3 times b times c plus 4. All right? And then you got a numerator and a denominator. So parentheses around all of this, 3 times x over parentheses, 3 times x plus 2, close parentheses, divided by, because now you have a denominator, parentheses, 4 times a minus 1. Okay? So we had, as programmers, we have to know how to break those things down so that we can get the right results in the program. So now, it says, unlike many programming languages, C++ does not have the exponent operator, right? But you have this command here called a POW, or POW. The POW function take a number and raise it to another number. So what happens here, in here, if I do, I think I can do this, upon include math.h. And then if I'll do something like this, well, I'll take this.
Is that the library you just called for?
Right. I'm calling that mat.h library, right. If I do int x equals 10, y equals 3, result. All right. Now, then I could say, result is equal to the power of x comma y. So what I've just done, I've raised what? 10 to the what? Third power, right? Which is what? 1,000. So when I run this, it should print out 1,000. See what I'm saying? So what happened is I said, okay, x is equal to 10, y is equal to 3. But result is equal to power of 3 to the third power. Well, this is the function, but it's like 10 to the third power, which is 1,000. All right? So that's what happens. You can take one number and raise it to whatever. All right, whatever power that you want to raise it. All right? And you do that with that power function. And then many other functions in C++ that can that give you results. All right. So here we go. Notice what happens. You have the power function. You have 4 raised to the second power. So 4 squared, in a sense, returns 16 into area. All right. So that's what happens. 6 raised to the third power. Or let's see. X is equal to 3 times this. Okay, so 6 raised to the third power, that's 6 times 6 is 36 times 6 is, I don't know, times 3, and that'll give you your results. All right? All right. And then in this one, see how, and remember I tell you, we don't like you to code this way, but It's not an error. 5 raised to the 4th power. So 5 times 5 is 25 times 5 is whatever times 5, and that's your answer. Okay, so that's the power function. Okay, so you can use that. So here you have area is equal to pi r squared. So all you had to do, if we knew pi could be a constant of 3.14. So look, area is equal to pi, and we had pi declared as 3.14 globally, or as a constant, times the power of r, or radius. They use the word radius to represent r, and whatever radius is, raise it to the 2nd power. So you see how you can use the math functions to rewrite the expressions, rewrite algebraic expressions. All right. And all this is just showing you exactly what happens. You they asked them to input a radius, and then now they found the area of a circle by having pi declared to be 3.14. Input the radius, and the radius is what? What's the radius? Half, right? Radius is half from the center point to the edge of the circle. So that's your radius times radius squared, and that'll give you your value. Okay? Now, let's go to, okay, that's still checkpoint. What's going on? Yeah. What did happen? Why am I programming this stuff? Tell me to get out all that going. Now it look like I done went to the end of the chapter. Am I loose? No, that shouldn't be loose. Okay. Trying to get back where I was. That was chapter 4. Chapter 3. Let's see what's happening here. Nope. Go back up. Yeah, see, and I get, okay, we're going to look at that. That's still in this chapter. All right. Let's see if I can find out where I stopped. Okay, we're going to get to character strength. Characters a little different from numbers, but like I said, at the same time, I think, oh yeah, set precision, we got to go over that. The manipulator. See if I can move this a little bit faster. There we go. I think I'm getting to, yeah, right here. So I think this is somewhere where we stop. That's it. Yeah, okay, yeah. All right. Come on. Yeah, I think this is it where we stop. Mistaken. How many books? Typecasting. Yeah, that's something we need to look at. It's useful. Oh man, overflow system. Okay. Right, that integer division, we'll look at that. I think this is right play. Minor right play. Class. I bet you. I think so. I think I messed up. Yeah, class. No, that's right. This is right. All right, so this is somewhere where we stop. All right, here we go. I'm finna say. Now, yeah, we did the grouping. So let me move this. I'm finna say. All right. Power. There we go. Man. All right, we did the pi. So this is where we stop. So now, momentarily, let's see when we get back into it. So, I keep having to do that. Okay, all right. So, when you mix apples and oranges, okay, let's see something. This is where we at. All right. So, when an operator's operating all of different data types, okay, C++ can automatically convert them to the same data type. This can affect the mathematical expression. And what that means is, like I say, depending on what it is, you can promote it to be used from integer to double, or you can have it stay the same when you lose or truncate the value. So you got to watch. And like I said, remember, you got long double, double, float, unsigned long, unsigned int. Unsigned meaning there's no sign. So that means you can store a larger number, but every number that you store will be what? Positive, all right? Of a positive integer. All right. So it says you will notice that char, short, and unsigned short does not appear in the table. That because anytime they're used in a mathematical expression, they're automatically promoted to int. All right, they're going to use them as an int. It's going to go to that ASCII table, grab their value, and you're going to use it as that value. All right. The only exception of the rule is when an unsigned short holds a value larger than it can be held in integer. Because remember what we said happens once you have a certain size that a value can be stored. If you go outside that limit, it just starts all over again. So you can have the wrong data represented, in your output. Okay. So when an operator works with two values of different data types, the lower ranking value is promoted. So that means what? If I have int and float, it's going to automatically promote it so that it can, if anything, hold values of that larger data type size. All right. So that's what happens. All right. So it says in the following expression, assume that year is int. So this would be int. All right. And interest rate is float. What it's going to do is going to say, okay, int divided by float, let's promote it. You promote it to a float where you can have a larger value stored in it. All right. So that's all it's just telling you. When the final result of the expression is assigned to a variable, it will be converted to the data type of that variable. All right. Of that promoted variable. All right. Now, in the following statement, assume that area is long int while length and width are both ints. All right. So these are both ints. Since length and width are both ints, they will not be converted. Remember, anything on this side, whatever it is, nothing is being promoted, so it's going to just store whatever to that side. However, it will be converted to long, so it can be stored into that area. But over here, there's no kind of promotion being done or anything. Just multiply those two int result to int stored into the long int. All right. Now, it says, watch out for the situation where expression results in a fractional value being assigned to an integer variable. We talked about that because what happens, it will truncate. It will cut it short. We have int x, all right, and y equal 4. So if we got float z is equal to 2.7, and we did 4 times 2.7, this will promote this side to a float, but we storing it into a what? An int. So it's going to truncate all of the integer, the decimal parts off. So you got to be mindful. Okay, so in this expression, X, Y, and Z, all right, Y times Z, Y is promoted, all right, to float, all right, and 10.8 will be the result, right? But since X is an integer, X will be, the 0.8 will be truncated, all right, and 10 will be stored into X. So, like I say, sometimes you might get away with it or whatever, but if you're dealing with precise figures, precise results, you probably want to make sure that everything does work and promotes as it should, and is stored in its proper sizes. Because you can run into problems. Because if just say take NASA. Now NASA just went went to Mars, and they have many different calculations, as to directions, whatever, however. And if they are fractions off from the Earth to Mars, they can end up way out in wherever, because if you take an angle and just tilt it, like say you at 0 degrees and you tilt something 2 degrees, and by the time you go from point A to 1,000,000 miles away, you'll be way off. So it makes a difference, all right? So you got to be mindful. All right? So now it talks about integer division. We pretty much talked about that, remember? Where we said an int divided by an int, I'm going to return an int, no matter what you're doing. 15 divided by 6, that's going to give you what? 2 point something. But what's going to be stored in parts? 2, right? Because what? An int divided by an int. But if you add that 0.0 here, now a float divided by an int, it promotes this. And now if this is a double or float, it will allow that point whatever to be printed, which we just did in our program. All right? Now, overflow and underflow. When a variable is assigned a value that is too large or too small in the range, remember we did the too large part because what? When we did a shorts and we added one number to the maximum value that could be stored, it what? Looped back and went to that minimum value on the back side. So you got to be careful, all right? So trouble can arise when a variable is being assigned to a value, all right, that is too large, all right, for its type, okay? Here's a statement where A, B, and C are all short integers, okay? If B and C are set to values large enough, all right, the multiplication will produce a number that's too big, all right? And what'll happen is, if you look here, it's not doing the multiplication, but it's doing the addition. This is the limit of a short data type. This is the maximum number value, in a sense, that can be stored in a short data type. 32,767. What they did was they added 1 to that value, all right? And then they output, when they outputted the value, they got the actual value, right? They added 1 to this value, right here, and look what they got. A negative 32,000, because that's the what? It looped back to the smallest size that can be, smallest number that can be stored into that variable. So it just did a loop back to the numbers, and it's gonna keep incrementing until they get to the end again and loop back. Because that's the only numbers that can be stored into, or size numbers that can be stored into that variable, all right? But then what they did, they took 1 away from it, which brought it back to what? This number here. So you went from a negative this back to this number. So you got to be mindful when you're creating your programs and you're giving them data types. You always want to make sure you have enough byte size to store the values that you want to display. All right, you always want to have a large enough byte size. Now, and this is your way to do E notation. Now, with E notation, we know that what? This here is 2E38. So all this is 2 with 38 zeros added to the end. All right. 2 to the E negative 38, that's with 37 zeros added to the left, because you got to count for that one position here. All right. So like I say, you could use the E notation. All right. Now, typecasting. What does typecasting does? What typecasting does, it allows you to use a variable, a value of a variable, all right, and change it to be used for that data type and the time you want to use it, but not affect the value, all right, or the variable. So look here, look what happened here. Double number is equal to 3.7. Okay, but look what they did. They said, okay, value is integer. Okay, but I want to assign the integer part of number into value. Now, they could have just done value is equal to number, and it would have what? Truncated to 0.7. But when you do static cast int number, you're saying, okay, I want to convert this double. I want to take this number that's double of double data type and put it as integer. You actually what? Truncating to the 0.7. So it's going to say value is equal to 3. Because what? You did a static cast of this, and it turned into the number 3. So value would equal to 3. Okay? So that's all that happening. And you can do that with letters, you can do it with floating point, whatever. So look at this program. In this program, what they're doing is they're trying to find out the average number of books a person or a student reads, right? So what they did int books, int month, double per month. Because what? Per month, you want to get what? Did they read 3.5 books? Did they read 2.8 books? Or whatever. You know, that's the average number of books. All right. So what they did, they ran in books, which is integer. They ran in months, which is integer. Now, books divided by months gives you what? An integer. So what would happen is nothing would be promoted. An int divided by an int, you would get 4. But they want that decimal place. Now, we can't say months 0.0 like we take a number and say 3.0. So what they did, they say, okay, and you could do it on any one of them. You don't have to do it on books. As long as it's one of them, and it's gonna promote that side of the expression. So look, what it did per month is equal to static cast double. So what I'm doing, I'm taking static cast double books. So it's taking books and taking it and putting it as a double. So now we have a double divided by int, which promotes the that side of the expression, and now it'll print out the decimal point. So you understand? So you can do it with the numbers by just adding point with 0, but to use the variable, excuse me, you have to do the static cast. All right? So that static cast would work to change that. All right? So let's see. So well, that's just with the power. But it'll work the same way. All right? Now, let's see here. And it's just showing you static cast, telling you what's going on. All right, so the results of the expression book divided by months is 4 in general, right? But when you use the static cast, which converts books to float or double, all right, then it allows it to promote that expression. All right. Static cast here. See how static cast char number. So all of a sudden now, remember, number is 65, right? But its char value is the letter A, if you remember that. So if I wanted to print out the actual the char value of a number, I can do static cast char number, or whatever of number I use. All right. So watch, I can do this, and what I'll do, I'll put in a loop. But don't worry about the loop. Let's see. And I was gonna try to copy it, but let's see. Okay, let's see. And I'll say, I'll say no. Okay, I think that's right. Oh, I don't have a number here, but let's see. I could do X. I'll say X. No, I'll do something like this. Don't worry about this statement here. We're gonna get to this. For it, X equals 60. X less than 100. X plus plus. And I'll do something like this. Do see out. Oh no, I just want one space. I'll just start it at the beginning. Static cache, T. I'll say number, and then I'll say X. All right, now, and so what happens is, I'm gonna close this. I'll close this, and this gonna perform X number of times. Now, let's see if I got that right. Static cast. No, yeah, char, yeah, that's right. Yeah. And the spacing really doesn't matter, but I'll just move it. All right, so what happens is I have X here as an integer, but in this loop, this is a loop, which is gonna start at 60. So it's gonna look at this and say static cast char X. So X is integer, but it's gonna print out the char value at 60. It's gonna print out 60, the char value, 61, the char value, 62, the char value, all the way up, and I'll put equal, less than or equal to 100. So watch what happens here, and I need to do an inline so it won't be all on one line. So I'll do an inline. All right. So now watch what happens here, and then we'll go debug. Let's see. Wait a minute. Okay, debug. So if we look at this, I didn't put a space. Let me put a space here. Okay. All right. So now, all right, debug it. Oh, I got an error. No. Oh, I'm streaming. All right. So now, debug it and watch. See here? 60 is the less than, character less than. 61 is the equal. 62 is the greater than. 63 is the question mark. 64 is the at symbol. 65 is the A. 66 is the B. So you see what happened? I took the integer values and printed out the char values, right? Now you say, well, is that right, Mrs. Sylvester? All we need to do is what? Go to our ASCII table. Remember we had an ASCII table? And we do ASCII table. We look at the ASCII table, where it's down here, and do it like this. And what? Let's look at it. It's okay. 60 less than, 61 equal, 62 greater than, 63 question mark. All right. Then 64 at symbol, 65 A, 66 B. So you understand? It's the exact same thing. Oh, where am I? All I did was printed out the numeric value and the decimal value, and then the the char value. Okay? By using what? The actual number, but converting it to doing the static cast to say I don't want to print the integer value. I want to print the char value. All right. So, what I said. I'll open up. I think I have programs for you to start working on. Let's see. That you can start with. Okay, and I'll open up that conditionals. Not yet. I'll open up the solo learn next class period so you can kind of get started with the loops. All right, so look at this. I'm gonna open up these programs, okay? Write a program that allows the user to input 3 integers. You're gonna input those integers and then produce the following output, all right? Determine if it's odd or even. Well, because we didn't go over the if statement, but I still want you to do it. Do it odd or even, yeah. I don't want you to do that one. I'll open that one up. And like I said, we'll talk about it on the next class period. I can't give it to you because we didn't get to this yet. I tell you what, don't worry about the assignments this time because I didn't even get to the manipulators. So yeah, we'll work on that because this one, you're gonna like I said, you're gonna have a value that's gonna be of integer, and I want it not of integer, but float that's gonna be a whole number, but I want it in 2 decimal places. I want one in 1 decimal place, 2 decimal places, 2 decimal 2 decimal. So we'll go over that. Then the alignment. So yeah, we never went over that, so we'll go over that. I'll go over that on next. We'll get to it next class period. Here again, same thing. So I guess just read up on your chapters. And so when I assign this, you'll be ready, and you'll have questions that you'll ask me. All right. So like I say, this week, just read up on your work and then have that program too. All right. So lad, don't worry about a program this class. Now I might put out a bonus or something and say, write a program and do whatever. Maybe. All right. Or I might say, do your resume. Go to student services and create your resume for bonus work. But I'm gonna give you something to do for the week. All right. But if there's no questions or whatever, on next class period, we'll have our assignments. We're gonna work on our assignments, and we'll continue on with the chapter. All right.
I have a question.
Yes, ma'am.
So only whenever we're dealing with a number having to be raised to a power whenever we're coding, is that the only time that we use the math.h library?
No, because you can do tangent, cotangent, what other math functions there are? You know, like the different mathematics, right? There's a library of math functions that's under the math.h.
Oh, okay. So for simple math stuff, you don't need to use math.
No. Modulus, add, subtraction, divide, no. But when you're doing like a random, it's a random function. You have to do load math.h. When you're doing power, like I said, you're doing tangent and cotangent, you have to use the math functions. Yeah. Okay. Right. So and that's how the different libraries are set up. And just like string, in order for you to use the string, in a sense, data type and different string functions, because there's something called string length. You can't use it unless you have that string library loaded. And then other different functions of string under that string library. You got me?
Yeah, so the math thing is kind of just like
just for math.
It built in, it's kind of like a normal everyday calculator, and then the math.h is like a scientific calculator.
Correct. There you go. And that's because what? If you're just a person that just want to write code, simple code, you don't need to worry about all those different libraries. But when you start getting deeper and deeper into more complex coding, then you would need to know, hey, I need this library to if I'm going to use this function and whatever. Right, correct. But that's right. That's pretty much how it works. Yeah, yeah, that's how it works. Because it's like, and just my theory. Back in the day when you wrote code in C++, C, or whatever, all those libraries was automatically loaded, which made your program what? Large, extremely large, right? You had all those libraries and didn't even need them. So what they did, they broke it down to where what? If I'm writing C++ and I only need these two libraries, then I could write my code, and considerably could reduce the number of lines of code, which allows the program to run a whole lot faster. You know what I'm saying? So I think that was one of the ideas behind having the different libraries. Now, it does cause issues when you first start coding as a programmer, and it's like you're trying to write code and you keep getting this error, and somebody say, an experienced programmer say, oh, I see you using string. You need to use this string library. Oh, I see you using, you read the input file. You need to use the fstream library. Oh, I see you using vectors. You need to use the vector library. You know what I'm saying? So stuff like that, come into play when you're trying to write code. You need to know what libraries you're going to need to load in order to use certain commands and whatnot. Yeah. Any other questions?
No, sir.
Okay. All right. If there's no questions, like I said, I probably post I think I got a resume bonus out there. It's for 50 points. Now, that bonus though, that resume, with that resume bonus, do I have it here? If not, I'm gonna put it. I'll add it. What I want you to do is I want you to contact, I'll go to the Career Services website, register, and then there's some utilities there, but I want you to create your resume. When you create your resume, you're going to submit it back to Career Services. They're going to give you tips as to what you may can add, or you may need to take away something or do whatever, and then you submit it to me. Then you submit the resume to me, and then I'll give you points for doing that. Now, one benefit of that is whenever Career Services get any type job offers, and you gave your interest and your degree and what your major is, they will shoot you an email saying, hey, this job has came available, such and such and such, whatever. And then you will be able to respond to those job notices. All right. And sometimes they be researchers, because NASA have researchers where they have students go and you can do research with NASA. Sometimes the state wants student workers where you can work, I think, up to 20 hours a week with the state. So it's various opportunities that'll be out there for you. So I would say take advantage of it. You can start creating your portfolio. I think it's a feature with Career Services where you can start putting together, like when you write code, put that in there, or other stuff you're doing in other classes. You can build a portfolio so that when you graduate or when you get an interview and the company asking you, well, what have you done and how you can actually show them and explain to them what it is you have done, and that'd be a lot better than just throwing out a resume. And then when they say, oh, I don't remember, this is what I have done, blah, 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 blah. So like I said, it's an advantage, and I want all of y'all to take advantage of that. But any other questions? And if there are no questions, hey, have a good, a safe week or whatnot. And like I say, do my work. All right?
Yes, sir. Professor, have a blessed day today.
Same thing. Bless you too, man.
All right, man. Be good, Professor.
Thank
All right. All right. Bye-bye. Okay.